Hey, what's up guys, my name is Eterno and welcome to episode 6 of Let's Make Flappy Bird. Today we'll be talking about loading textures into our game, as well as buffers. Since we want to be able to use textures in our game, we need a way to go from an image file to something that can be displayed on our screen. The workflow is pretty simple. Firstly, we need to load our image file. Then we'll grab the pixels from that image and finally use them to create an OpenGL texture. There are a few things to pay attention to in this process, and we'll address those things as we write them. Let's make a class called texture which will represent a texture that will load. I'll put this into a package called graphics since it refers to the graphical aspects of our game. We'll need to define a few fields to hold important information, such as the width and height of the texture and the ID that OpenGL will assign to the texture when we create it. This ID will be used to activate our texture when rendering. I call this field texture, but you can call it ID if it makes more sense to you. Let's make a constructor that takes in a string. This will be the file path of our texture. We'll leave it blank for now. We'll make a private method that also takes in a string, again being the file path. This will be a rather large method that will essentially do everything from loading the file to creating the OpenGL texture. It'll return an integer, being the OpenGL ID for the texture, which we need to assign to our field. Firstly, we'll use a buffered image to load our image file, using image.io.read with a file input stream. This will throw some exceptions, so let's surround that line with a try and catch. We can get rid of the file not found exception since IO exception includes that. Again, handle them properly if you wish, we're going to be keeping it simple. If the image file is loaded successfully, we'll have all the data we need in our buffered image object. So let's set width equal to image.getWidth, and then do the same for height. We'll create an integer array called pixels that will contain all of the pixels in our image, with each integer in the array being the color of the pixel, and the index of that integer referring to where the pixel is located in our image. Inside the try block, we'll set the size of our pixels array to be the size of our image, as soon as we find that out. Now let's call image.getRGB with the appropriate parameters, including our pixels array. Arrays in Java are passed by reference, which is why getRGB doesn't need to return anything. It will simply set our array through the parameter. What we have now is an array of pixels which makes up our texture. Before we can give it to OpenGL though, we need to change the format of it to comply with what OpenGL wants. Basically, we just need to move some bytes around. Each color in our pixels array is represented as ARGB, alpha, red, green, blue. That's the order of our color channels, because that's how buffered image loaded in our pixels. If we look at an example color in hexadecimal format, what this essentially means is that the leftmost two digits represent the alpha channel, then the red, green, and blue channel. Whilst we can tell OpenGL to use a variety of formats, none of them suit this one. The easiest and most practical to adjust to is RGBA, or ABGR if we read from left to right. So as you can see, we need to move around the ordering of channels. Luckily this isn't too difficult to do if you know what you're doing. First let's make a new integer array called data which will store this new format of pixels. Obviously it will be the same size as our pixels array. Now we need a for loop that will iterate through each of the pixels in our array since each color needs to get reformatted. For each of these colors we need to extract each channel, which can be done by masking it using the bitwise AND operator, and then shifting it the appropriate number of bits to get it to the rightmost bits, the start. For example, let's take a look at the alpha channel. It's the leftmost channel, so we need to AND it by FF000000, which will preserve just the required bits, and finally, move it to the right. Since each of these hex digits represents 4 bits, we need to move it a total of 24 bits to the right. The leading zeros have no effect, just as they wouldn't with a decimal number. So we're left with just the alpha channel. Nice. Once we've extracted all the channels, let's put them back together in the correct order to comply with our new format. The alpha channel will go back to where it was, no change. Then we'll use the bitwise OR operator to combine the other channels. Next, blue will go to where red used to be, green will stay where it was, and red will take blue's old place. Now we've got our new array, data, populated with pixels that are in the right format for OpenGL. We used a lot of bitwise operators and bit level calculations here, so make sure you research and understand them. I might make a dedicated video in the future explaining them in depth, since they're quite important in graphics programming. The last step is to use OpenGL to create this texture from our pixels. Firstly, we'll statically import GL11. Now let's generate a new texture and assign its ID to text for now. To activate this texture for use, we need to bind it using GL-bind-texture. It's a 2D texture, hence the texture 2D flag. We'll pass in text since that's the ID of the texture we want to select. Now that it's selected, we can modify and use it. Think of this like selecting a layer in Photoshop or any other similar program. We can't modify it if it's not selected. Before we feed our pixels into this texture, let's set two important parameters. Basically what this will do is disable anti-aliasing for our textures. We'll be dealing with some lowish resolution graphics, particularly for the bird, and we don't want those textures to be blurred if our game runs at a high resolution. This will keep our textures nice and sharp. As I mentioned 2 episodes ago, LWJGL doesn't want arrays, it wants buffers. We'll need a way to convert arrays into buffers. Let's make a new utility class for this, since we'll need this quite frequently. We'll pop it into our util package and call it bufferutils. LWJGL actually has a very similar class, but our one is going to be slightly different. This will be a static class, so once again let's add a private constructor. In this series we'll need to use byte buffers, float buffers, and of course int buffers for the pixels we just created. Let's create a static method which takes in a byte array and returns a byte buffer. Don't forget to hit Ctrl-Shift-O to import things, as we'll be doing this throughout the series. We'll create a byte buffer result and allocate a new direct buffer with the same size as our array. We'll set the order to be native order, which is what LWJGL wants. Next we'll put the array into the buffer and flip the buffer. Flip basically flips the buffer and prepares it for reading, again something LWJGL wants. That's all we need to do to go from array to LWJGL compliant buffer. Let's duplicate this method twice and adjust it for use with float and int buffers. The only real difference here, apart from changing the types and appending the asFloat or int buffer, is the size of the allocated buffer. Since we're still technically allocating byte arrays to begin with, the size needs to be in bytes. 1 byte in Java takes up 1 byte, however floats and integers both take up 4 bytes, which is 32 bits. Because of this, we need to multiply the size of the array by 4, or shift left 2 places, which is mathematically identical to multiplying by 4. And that's our bufferutils class. Back in our texture class, let's use this new functionality. We'll call GL-TextImage2D, setting our format to be RGBA, the width and height to the appropriate values, the type of data to be GL unsigned byte, and finally feeding in our data array by calling bufferutils.createIntBuffer data. You might accidentally be using the LWJGL version of bufferutils, so scroll up to the top and make sure that you're not. You need to use the one you just created. Note that we use GL unsigned byte as the type. Colors are essentially unsigned bytes, meaning they range from 0 to 255 inclusive. Java unfortunately doesn't have unsigned types, and Java's signed byte is rather useless to us since it ranges from -128 to +127 inclusive. Because it can't store anything above 127, and we need to, we have to use another data type such as int. Short would have also worked, but I chose to use ints. Finally, we'll unbind the texture since we're done with it and can now deselect it, so that we don't accidentally use it in the future. We'll return our text integer, which holds our ID, and we are done. Our textures are now ready to use in OpenGL. I'm going to go ahead and add getters for the 3 fields we have, since we'll need to access them in the future, particularly the ID. I'm also going to go back up to the constructor and assign the texture field to our load method, with the path as the parameter. And that's it, our texture class is done. We can now easily use it to load images into our game and use them as OpenGL textures. Fantastic. Thanks for watching and I hope you enjoyed the video. As always, a like is greatly appreciated. Next episode we'll be rendering an object onto the screen. Goodbye.